Hello, this is Andrea Hendricks, and I want to talk to you about a second type of rational function that we need to graph. These are the ones that have holes in their graphs. And if you will recall, the graph of a rational function will have a hole in the graph if x equals a is a zero of the denominator and x minus a is a common factor of the numerator and denominator. So the steps that we're going to go through to graph a rational function with a hole are basically the ones that we did with the other type. We're going to add an extra step, which is factoring the numerator and denominator, because in seeing common factors we'll know if we have holes or not. So factor the numerator and denominator, find the zeros of the denominator because that's where you'll have either vertical asymptotes or holes. Then we're going to factor the numerator to determine if we can reduce a fraction. If we can reduce it with one of the factors in the denominator, then we have a hole at that particular zero. Find the zeros of the function, the y-intercept, the ordered pair of the hole, any horizontal asymptotes, sketch the graph with additional points if we need them, and state the domain and range. So a lot of the steps are going to be similar to what we've already seen. So here's an example. Really, just from looking, you don't know if it has a hole or not. We have the function 2x squared minus 4x over x squared minus x minus 2. So we need to factor the numerator and denominator, and whenever we do that, we'll get this expression. The numerator will simplify to be, there's a 2x in common, so we can take a 2x out, and that leaves what? X minus 2. And my denominator, in fact, let me write this over here. I didn't leave myself enough room, did I? The denominator factors as what? X minus 2 times x plus 1. So where will we have vertical asymptotes or holes? Where those will be at the zeros of the denominator, which are at x equals 2 and at x equals negative 1. Well, we need to reduce a fraction, and notice we can reduce it. The x minus 2 is a common factor. So that means at the x equals 2 we're going to have a hole, but at x equals 1 we are going to have a vertical asymptote. So we have reduced the fraction as much as we can. So let's think about what the zeros are. The zeros now are where 2x is equal to 0, which is at x equals 0. And now we need to find the y-intercept. We plug in 0 for x. So we would get 2 times 0 over 0 plus 1. Which we know is 0 over 1 or 0. Now let's go back to find the ordered pair of the whole. So we know the whole occurs when x is 2. We can't plug it into the original form because we would get 0 in the denominator. So we want to plug it into this remaining expression, which is 2x over x plus 1. So if we plug in, what, 2, we would have 2 times 2 over 2 plus 1, which is 4 thirds. So that means our whole will be at 2 4 thirds. Now, do we have a horizontal asymptote? Yeah, the degree of the numerator and denominator are the same. They're both 1. So if we divide the leading coefficients of that term, we would have 2 over 1, which is 2. So we have a horizontal asymptote at 2. Now let's sketch the graph. Okay, so we need to plug in our vertical asymptote, which is at x equals negative 1. Okay, let me move that over just a tad. We know we are going to have a hole at 2 4 thirds. So 4 thirds is 1 1/3. So we're going to have to just approximate there. We also know that we have a horizontal asymptote at y equals 2. So let me just change the color of that just to distinguish it. So y equals 2. Now we need to probably plot a few additional points so that we can figure out what's going on with the graph. I do know one other point I can plot, and that is my y-intercept and x-intercept are both at 0 0. Now, I didn't talk about this, but can the graph in this particular case cross the horizontal asymptote? So we need to figure out, does 2x over x plus 1, does that ever have the y value of 2? So if we cross multiply there, we would get 2x equals 2x plus 2. Subtracting the 2x from both sides gives us 0 equals 2. So that's no. So that means that the graph will not cross the horizontal asymptote. Now, knowing that tells us what the graph is going to look like in this region to the right of the vertical asymptote. Since we can't cross the horizontal asymptote, all these points have to lie below. And so that's going to give us this shape. Remembering that that is a hole, so we're going to continue on, look like that. So we're getting as close to that line y equals 2 as we can without really touching it, though that's very hard to distinguish exactly. So now we need to figure out what's happening on the other side of the horizontal asymptote, or vertical asymptote rather. So let's plug in something to the left of negative 1. So let's plug in negative 2. If we find f of negative 2, we would have, what, 2 times negative 2 over negative 2 plus 1, which is negative 4 over negative 1, which will be a positive 4. So at negative 2, we have a y value of 4. Now again, knowing that I can never cross a vertical asymptote, and in this case I'm not going to ever cross my horizontal asymptote, all the points then are going to lie above the horizontal asymptote in this region. And so we're going to have a shape that looks like this. Now, what about my domain and range for this particular graph? Well, the domain again excludes the values that make the denominator 0. So that is whether we have a hole or a vertical asymptote. So we're going to have to exclude the values of negative 1 and 2. So we would have negative infinity to negative 1, union negative 1 to 2, union 2 to infinity. Now the range is going to be a little bit trickier here because look what happens. Remember, we're reading from bottom up. We start from the bottom, so we have values from negative infinity on up, except where this hole is, right? We don't take on that y value, which is at 4/3, but then we go above it, approaching the line y equals 2, but never crossing it. And then we pick up above the y equals 2. So the range here would be from negative infinity to where our hole is, which is at 4/3. Then union 4/3 to 2. Oops, not infinity there. Let me back up. And then union all those points above the horizontal asymptote, so those go from 2 to infinity. So a little bit trickier. Now, let me show you how to do the graphing calculator. I've pulled up the graphing calculator and I've entered my function 2x squared minus 4x divided by x squared minus x minus 2, again with the numerator and denominator in parentheses, and I'm going to press graph. Now I've put my calculator again in the dot mode. Sometimes this is a little bit finicky, I guess I'll say. Sometimes you have to actually graph it in the connected mode and then go back and put it in the dot mode and regraph for it to show the dot mode. I don't know why it does that, but if you find out any easier way, let me know. So I have it in the dot mode, or again you can go to Z decimal, zoom, and 4 and see sometimes a better picture. The problem with that is your graph may go out of the dimensions that we've set for our windows. Now here's another tricky thing. It will not always show the whole. So if you want to see the whole, you can go to the table. Okay, that's showing me my horizontal asymptote is 2 because of the way my table is set up. Let me change my table to start at 0 and increment by 1. Okay, so notice that we have an error at 2 and we also have an error message at -1. So that's going to tell me something weird is going on at the 2. So just to reiterate that fact. Okay, but that does confirm the shape of our graph, and what we have done thus far by hand is correct. So if you have any questions about how to deal with holes, really just I'll summarize this one more time. The hole occurs when we have a factor that reduces out. So that does not make a vertical asymptote there, but at a hole there. And then you need to find where the hole occurs by plugging in that x value into that reduced function. So you'll put a hole at that graph, and then everything else is really the same. So contact me if you have any questions. Thanks.